Hello everyone. So today we are going to do Leetcode daily challenge. Minimum number of refueling stops. So basically in this question, we are given with a car travels from a starting position to a destination which is target miles east of starting position. So here basically we don't need to consider about the direction. We just need to consider that it's just target miles away from the starting position. And then comes the part, there are gas stations along the way. The gas stations are represented within the array of stations. Basically, this would be a 2D array or 2D vector, means basically a 2D data structure, in which if we consider the inside one, then that particular vector or array would be something like this. That is stations of I equals to position of I, comma fuel, where position I simply represents that how much it is farther from the starting position, and fuel I simply represent that how much fuel it can fuel up to our car for getting ahead. And then next it says the car starts with an infinite tank of gas, initially has start few liters fuel in it, because if it don't have any fuel then we won't be able to go ahead, that's why. And then it uses 1 liter of gas per 1 mile it drives. So this is the best thing which we got here. So that's why we can use the position and fuel interchangeably in this question. And then next comes the part that when the car reaches a gas station, it may stop and refuel, transferring all the gas into the car from the station. So that simply represents that there is no fuel loss, so you could directly add that up to the fuel of the car. So that's the thing they want to represent. Then at the end, we need to return the minimum number of refueling stops the car must make in order to reach its destination. At the end, we just required to return the minimum number of refueling stops that the car is required to make. And that is the thing which we are required to think here, that how we are required to get the minimum number and the best possible result. So if it cannot reach a destination, then we are required to return -1. So the thing is that in this question they are explicitly mentioning that there could be a position where our car is basically not able to reach our destination, means either the fuel, the starting fuel, that won't be sufficient enough, or in the middle if we reach at some position when we are not able to go ahead. So that's why at that particular moment we are required to return -1. Else in some questions there it is directly given that the fuel is sufficient enough to reach the target and so on, like that. But here they are mentioning that you can return -1. There could be an instance when you are not able to reach the destination. So that's why we are required to keep a check on these test cases also. So now they are also mentioning that note that if the car reaches a gas station with 0 fuel left, the car can still refuel there. So the thing which they are mentioning here is that if we get fuel with us, and after reaching that station, just before reaching that, means just to reach at that point, our fuel becomes 0. Then also we can consider that we were able to reach that particular position, and when we reach the gas station, then we will be easily able to fuel up and go to our next station or to the target destination. And the next line they are mentioning that if the car reaches the destination with 0 fuel left, it is still considered to have arrived, because it has reached the destination even if it don't have fuel in it. So that's the thing which it is mentioning here. Now comes the next part about the examples, but let us first check for the constraints. So here it is mentioning the target and start fuel is basically less than equal to 10⁹. So this is pretty much important to get to know that if we add up all of them, then it could go more than the range of integers. So that's why the data structure which we would be required to use would be either unsigned int or long. Then we would be adding them up. So that's why they are giving us the constraints here that it could reach at max 10⁹. And then they are mentioning that the station length is basically till 500. So this simply represents that traversing the area which is being given to us. So at max there could be just 500 stations, right? So our solution could be order of n also, order of NlogN also, order of n square also. So that's why here at max order of n square solution would easily work. So that's why we can consider this particular constraint the indication of our time complexity. And here it simply represents that our positions are basically sorted in increasing order, and the fuel is basically up to 10 raised to power 9, so that we could easily reach our target. So this is the thing which is being given to us in the constraint. Now let me show you the explanation, or you can see the better more examples which I just derived. Basically this question was asked in one of the Google interview also, so that's why it is pretty much interesting even when I solved it. So it was really interesting, and it became one of my favorite question, and thus now I've derived some more examples from my own self also. So here if we see, the target is basically 60 and the start fuel is basically 50, right? So when the start fuel is 50 and the target is 60, right? So this 50 simply represents that we can skip this 10, 20, 40 and we could directly reach this 50 and get whatever fuel is there. But we need to keep a check that it should be able to reach this 60 also. Means minimum 10 should be there. That we need to keep a check. And if it is having more than 10, then yeah, we are easily able to reach our target destination, and thus its answer is 1. And the example which I have taken here, if that was not the fact, means we were having here fuel just as 5, then surely we would be have checked other options also, then the answer would have differed. That is the thing. So here 2 parameters are there, that can we reach at that fuel station, or the fuel which we are having to reach that particular fuel station sufficient enough, and after reaching that fuel station, would we be able to reach the other fuel station or not? But reaching other fuel station from that fuel station, then that is also the scenario here. That will return -1, means there could be a scenario. That we will come up with other examples, but here that is confusing more. Here this example is directly about stating that if our start fuel is sufficient enough to reach at that particular position where we get the maximum fuel, like here we are getting the maximum 200, so then at that position we can directly reach at that, and thus our answer would be directly 1. So that's the thing I wanted to explain from this example. And then in this particular example, our target is 60, starting fuel is 15. So if we try to choose this 20, we can't. Then we are obliged to choose this particular 10, right? And then choosing this 10, we would be having this 10 in our fuel. Then we would be obliged to reach this 20, because till now we would be having fuel which is less than 50, like this 10, 10. Then we would be cover 10 distance and fuel would be 25 after reaching this, because earlier we were having 15, right? Then 25, and then this particular we reached at this distance and our fuel is 55. Then we can easily reach this 50, because 55 is the fuel we are having, 5 would be still extra with us. And when we reach at this 50, we got this 60, and after this we are easily able to go to a 60 target. So here the worst case scenario has been occurred, that we were obliged to use all 3 stations. So that's why answer is here 3. Now let us take another example. Here 10, 20, 20, 30, 30, 50, 60, 80. So here our target is 100 and starting fuel is 20. So here we can check that 10, 20, if we take that and if we take 20, 30, which is giving us more fuel, is it 21? And we are having starting fuel as 20 also, right? So in this scenario, the most optimal selection would be this one, right? So we will choose this, and our starting fuel will now become as 50. And after it becomes 50, then we can easily go to this one also, and going to this we won't be able to go. So that's why we will be choosing this, and then we will add this 50 to our answer, and we will get the starting fuel as 100. And after getting our starting fuel as 100, then what next we would be doing is, we can easily reach our destination 100. So that's why here the answer is basically 2. That is, we chose this particular and this particular. So now after this example, let me show you that how we can come up with the algorithm. So after all these, you would have been clearly thinking about it, how we are working in this. Like even before thinking of a data structure, let's think about what algorithm we need to design. We need to check, is that present situation, that is the gas station, capable enough to be reached? Because it is the most important criteria that we can reach that gas station. If we are not able to reach that gas station, that what would be the fun of getting the most fuel from that gas station. So that's why first would be that we are required to check that are we capable enough to reach that gas station, and could that gas station provide us best possible fuel in that scenario. So these are the two conditions which we need to keep in mind and go ahead. So this all comes up for our first criteria which we need to think, and you can here clearly see that it comes up like that we are checking for the local maxima or local minimum situation, right? So after choosing the local maximum minimum, then we are arriving with a global maxima or minimum situation. So that's why this question becomes solely about the greedy approach. That we are selecting what the maximum thing which we can get at a local level, and then ultimately at global level we are getting the maximum. So that's why this is greedy. And now comes the next part, that if we got new station added to our present fuel capacity, then would it be able to give us target, or we need to repeat the process again? So this is the next thing. After choosing a present gas station, we are required to check. And now comes the part that how can we do that? Can we do it directly, or do we require some data structure? If we would be required to do it directly, then surely it would become much more complex, because we are at every moment required to have the maximum maximum capacity, and after that maximum capacity we would be able to check for the next one, that what is the next capacity which we could take in. So that's why it's better to choose a data structure rather than complexing the situation of our algorithm. So that's why now comes the part that how we can figure out with the data structure. So think of a data structure which dynamically sorts as some new elements come into it. So that data structure is directly a priority queue. And then think of a data structure which removes element easily, or accessing that elements become much easier. So in that criteria, map, unordered map, and priority queue all are preferable. But satisfying both of the criteria, we can see the priority queue becomes the best, and that's why we would be using here priority queue. And the solution would be order of NlogN, just because in the priority queue, the sorting part would be there, so it takes the login time, and when we are collecting all the data together, then it becomes NlogN, and at max it would be order of n space complexity, because you can see even in this example which we took, when we were choosing all three. So in the worst case scenario, we would be using all the space. So that's why now we need to consider about data structure. I've already explained. Now let me show you the code walkthrough for this particular question. So here comes the part about the coding. So here it is. So the first thing which we are taking here is, we are taking int I equals to 0 and result equals to 0. And we are taking priority queue where fuels would be added, and as we are using C++, so here priority queue is already in the form of max heap. So already in the top maximum element would be there, because we require the most optimal that, and here the most optimal simply refers to the place where we can reach, and that particular station where we would be having the maximum fuel. So that's here represent about the optimal, and that would be already stored in this priority queue topmost element. And now we are running two loops here. So basically the first loop is for consideration, that is our current fuel basically less than target, till then only we would be going to check, because what we are doing here is we are fueling up to reach our target, because the thing is that it could be our current fuel is that much sufficient enough that we could directly reach that. So in that condition, we won't be entering this loop, we would be directly returning this result as our answer. So that's why we are keeping our current fuel less than target, then only we are moving ahead. So when we enter this loop, then we are incrementing our result. We enter this loop, so we would be at least fueling up with at least one would be there. So that's why we are incrementing our result, and then we are going ahead with this loop, and this loop is basically for the functioning of a priority queue, that we will keep a check, that is our index less than size of our input vector or not. If it is, and the next thing would be that is our station having that much fuel? Basically, here in this particular condition, we are checking that is that particular station is that much far away from our present fuel that we can reach it or not. That's why we are putting here. Here we would be having the path, basically the position of our next station, and we will be checking that is our current fuel sufficient enough to get to that station or not. If it is, then we will be pushing that particular station and the fuel which is there in it into our priority queue, and then we will check, means when we come out of this particular while loop, then we will check that is our priority queue empty or is it really have something. If it is empty, that simply means that we were not able to get any fuel, right? So we will be directly returning -1 through it, and that would be our answer. But if that is not the case here, then in that criteria, we would be directly adding up the topmost element of a priority queue into our current fuel. That is, this is the most optimal station we can reach, which is feasible by the distance we can cover up to that particular fuel, and even this is that particular station which is having the most optimal fuel we could consider in that much distance, and then we will directly pop that out. And at the end, when we complete this particular while loop, then we would be directly returning our result. So this was all for this particular question. If you like the explanation, do like, comment and share this video, and please do subscribe to my channel if you are a new viewer. And if you have any doubt about this tip, you could actually comment that down. So yeah, this was all about this video. Thank you.